good tips from you all as well. But yeah, so I think, teaching kids how to code, when I was younger, first in the 90s, learning how to code, like the type of stuff that's out there today, when I learned about it, just blew me away, because I'm like, what? Because you can even, there's even tools now for pre-readers and early readers. So kids as young as 4, believe it or not, you can teach them coding concepts. So that's what I'm going to talk about today. Now let me get moving here. We talked about me. I'll go through this real quick. Pretty much, we're going to do an introduction. Why kids should even bother to code. There's so many activities out there, like why do you want your kid in front of a screen for even longer? How kids are learning to code. Then I'm going to talk about 2 different really popular coding platforms that are out there. There's a bunch, so it's not just limited to these 2. I think these 2 are probably the most popular and easiest path to entry. I'm going to do actually a Scratch with me, so if anyone has not done Scratch before, it's a block-based coding language created by the folks up at MIT. So we'll do a quick Scratch with me. I don't think we're going to have a time for a similar project in code.org, but maybe. And then I'm going to show you some examples of some of my students' work. So we're talking like 8-year-olds, 9-year-olds, might be a couple of 10-year-olds out there. So that's what we're going to get through today. All right. So the big question, why kids should learn how to code? Because, nobody wants their kids in front of a screen. I will say some of the coding things, even today, that I'll walk you through, you don't necessarily have to do it in front of a screen, which is pretty cool. But problem solving. Everybody wants their kids to be great problem solvers. And I shouldn't assume, is everyone in here a programmer? Can you raise your hand if you are a programmer? Ish. Okay. So I guess you guys know it, right? If you're a programmer, you have to know how to problem solve. Somebody comes up to you and drops something on your lap, and you got to figure out by tomorrow how to get it done. So problem solving is really important for kids. It applies, and for adults, of course, but it applies to every discipline. So you can really learn some really good skills through programming that you can apply to every other area in your life. That kind of leads me into creativity. So when I talk to parents who are not IT people, this one to them is like, what do you mean they're going to be creative? Because there's kind of a misperception that programming is not a creative activity. Not anybody who programs kind of thinks, well, what are you talking about? I'm very creative. But the thing about creativity with the kids is, especially at a young age, like, you got to grab them. One of the pre-survey questions I ask my kids is, how are your feelings about this? I have to be good at math. And so a lot of them believe they have to be good at math, and a lot of them think I either hate math or I'm no good at math, therefore forget about programming. So in my mind, I'm talking about young kids, kindergartners, I want them all to learn how to code. So it's a creative process. You don't have to be good at math initially. Maybe certain things, programming, you have to get better at as you get older. But it shouldn't be a barrier for kids to think, no, it's not for me because I hate math. So it's a very creative process. We're going to talk about teamwork. Now especially the one platform I'm going to talk about today, code.org, they actually have a pair programming feature built in. So that's pretty cool. If you're teaching it probably in a school, you might have to be a little careful that not one person's doing all the work. But it simulates real world. I think it's another misperception for non-IT people is that programmers just kind of work in isolation somewhere in a dark room, and some of that's true sometimes. But we're usually on teams. We collaborate with each other. We share ideas. I sit next to you because you need a second pair of eyeballs, and you're talking things out. So even that, learning how to think out loud, kids in regular school, they have to think in their brain because you can't have 30 kids thinking out loud. It's just way too loud. So even that concept of, you have to think out loud so your partner can understand kind of where you're taking this thing. So coding is great for that. Now digital literacy, I like this one because this is the new literacy. But I think I don't know if we're all guilty of it, but I am guilty of it. Got a new phone for Christmas. My old phone sucked. My daughter, who's in 5th grade, picked the phone. She gives me this new phone. I have no clue how to use this phone. I just don't know how to use it. I went from, I don't know, it's like some cheapy thing we got on Amazon Android for 150 bucks, worked great for years until it didn't. So I got an iPhone. I don't know how to use the thing. So what do? I give it to my 10-year-old. And she comes back and she teaches me how to use it, which is kind of embarrassing. But kids today are just like innately knowledgeable about how to use things. Doesn't mean they know how to create things. So it's a totally different skill set. From my perspective, I want my kids to know how to create things. I don't want you just using things all the long day. So if I see somebody playing a video game, I think, but you can make something similar, and then it's yours. You can make it as evil as you want. So I have some really evil students who like to torture me. And so, you know, for making a video game, they love this Flappy game that you can do on code.org. It's a really easy intro game. And so, you know, it's flap the bird, and you have to go through the obstacle course. That's the basis of the game. And so they'll do stuff like this because they're evil. You know, normally, you go through the obstacle, you get a point. You go through the next obstacle, you get another point. If you hit the ground, okay, you die. But you know, you have kids that do this. First of all, there's arrows, up and down arrows. Maybe I'll just reverse the arrows so that you think you're flapping one way. Or maybe it's, you know, every time you go through an obstacle, I clear out your points. So they kind of do stuff like that and they think it's hysterical. And it is hysterical. And that's what I want them to think. Like, you're being creative, you took this template of a game, but now it's your game. Especially once you tell them they can make it opposite day and do whatever they want to. And then the final thing I want to talk about, why kids should learn to code, is diversity. I don't think it's a big secret that the world of tech is not a very diverse world. And I think, especially, I kind of figured this out when I was working with my Girl Scout kids early on during COVID. It does not take very long in a child's life for them to self-select out and say, yeah, it's just really not for me. So you can kind of see this. I do coding clubs, and you'll see, so these are kids who are self-selecting in. I think I like coding. I want to sign up for a coding club. Let me convince my parents that I want to go to coding club, right? Majority are boys. Not that there's anything wrong with being boys, but I would love girls. Whenever I see girls showing up, I'm like, oh yes, we got some girls interested. So anyway, part of me thinking that why kids should code, especially young, they just build an awareness about what's out there. They're not self-selecting out. All right, so now I get to do the fun stuff. How kids code. I talked about earlier these unplugged exercises. So a lot of times I'll do something like this with kindergarten. And, you know, you don't want them on a screen. There's actually, there's like Scratch Junior, there's Scratch Junior and other tools which are for early or non-readers. But to be honest, sometimes when you're just starting, and especially if you go to a community center where maybe you're just there for 1 hour, like you're just doing an hour of code, getting everybody hooked up and onto Scratch Junior, like your hour's almost gone if you have 20 kindergartners, because they just struggle. So I do something like this, which is an unplugged exercise, you know, just a regular piece of paper. This is an old CD-ROM start guide. I don't know where I got that from. Anyway, you know, if you hold the paper this way, kind of looks like a hamburger. You hold it this way, kind of looks like a hot dog, right? So the challenge for you, we're going to learn about algorithms today. The challenge for you is how can you make 16 equal, well, they won't be squares, they'll probably be rectangles out of a single sheet of paper. What's the algorithm to do that? So I'll say, okay, so are you going to do a hamburger fold, or are you going to do a hot dog fold? So if we try to do it now, like what's the first step? Anybody?
Hamburger.
Sorry, so somebody keep track. We're doing one hamburger. And now we have 2 equal rectangles. What now?
Hot dog.
Oh, you're going hot dog. I love when the kids go hot dog, because I never think to go hot dog. Okay, so I got 4 rectangles now. Almost there. It was hamburger, hot dog, right? What
Hamburger.
next? Another burger. So I think we're at 8. I need 1 more. Which way am I going to go?
Hamburger.
All right, so let me see if that actually worked. So it's hamburger, hot dog, hamburger, hamburger. That was the lesson, right? That was your algorithm as a class. And it's going to be 16. We all know it's going to be 16, and it's 16. But the question is going to be, that's our collective algorithm for how to get 16 squares doing hamburger, hot dog folds. But if I said we did 4, can we do it in less than 4? Can you do it in more than 4? Can you make another? So it's just getting their brains thinking, like, what's a different way I could do it? It's a very simple exercise, And honestly, if you're with kindergartners, that might take up half an hour, 40 minutes, because they're going to be like, wait a second here, I want to try, I'm going to make individual squares. They're going to try all different kinds of stuff, only to realize if you want them equal, you're going to have to do, you know, hamburger hot dogs. I think you can actually do a bunch of hot dogs and potentially get it, I'm not sure. So that's just a simple example of a unplugged activity. There's a bunch more you can do. The one I really like, oh, I should have brought an example of it. But you can imagine a 3x3 grid that has, say it has an X design. So the upper left quadrant, the upper right quadrant, lower left, lower right, and the middle all have an X in it. Sit back to back with your partner who has an empty grid, a 3x3 grid. And your job is to tell them what's the algorithm to make that design. Increases their communication. They're laughing like crazy. They might get it right, they might get it wrong. The next step from that would be put code to that. So you're going to use errors or something, so you're going to code your algorithm. So that's the next like logical step. But easy things to do, don't even need a computer. We're going to talk about coding platforms. This is an example of a Scratch program. I don't know which one that was. Oh, this one was a really cool one. This one I had a bunch of 5th graders actually work together. And I'll show you that project at the end. But you can really start taking these programs into uncharted territory in a way. So people think video games, maybe you're thinking maybe animations. This was, we ran a food drive, built a structure out of the cans and boxes that we collected, hooked it up to some circuit boards and made the thing talk to the food bank when they came. So it was an interactive structure. So anyway, we did that through Scratch and one of the tools I have up here. Oh, that leads me to this. So our physical computing. So there's a bunch of different things. Scratch especially is good for this, where you have other plugins that you can do. So this is an example of just a simple circuit board. I have one up here called Makey. Oh, I have one on my neck too. So this is like a really quick one. And it's just really cool. It's a lesson extender. So you can kind of go from this. Now we're going to write some code. Now, let's get the code off the screen. Well, how do we do that? Whoop, not like that. Well, I would be on the screen. You can hook up a Makey. There's Arduino. There's a bunch of different devices that are external that can have you doing physical computing with the kids. So it's another step beyond. A lot of STEM teachers especially will like this one because you can take whatever lesson. It can be a social studies lesson. And part of the social studies lesson is you're learning about Canada, and so all your kids have to make a poster about something they learned about Canada. Okay, so it's a flat poster, separate, there's no coding going on yet. But again, similar to that structure that I talked about earlier, why not make it talk? Why not when I hit the picture of, oh, what's the French fries with the gravy called? Poutine. Yeah, so when you write and you have a picture of poutine that you spent all this time drawing and it looks so lovely and delicious, and then you touch it and it makes like a sound. Like, kids love that stuff. So anyway, that's just something that you can add on as you're getting a little bit more past coding and into physical computing. All right, so we talked a little bit about two platforms. Code.org. So if you're a programmer and you're thinking, I'm not a programmer, teach kids how to program. And then you start talking to a kid and they're just like, what the hell are you talking about? Code.org is a good place to start because it's all set up for you. The flip side of that is if you're a teacher and you don't know how to code, it's a great place to go because it's all set up for you. And if you're anything in the middle, it's a great place to go because it's all set up for you. They have a bunch of project templates. So the kids can easily go in and just start from something. You're not starting from a blank space. Starting from a blank space is scary. Right? So just like writing a paper back in the day when you were in school, teacher gives you an assignment and you start with this blank paper and you're like, oh my God, how am I going to get this done? So code.org is good because there's a lot of template work in there. They specifically work with Hour of Code, which is in December typically. So you can go to an hour of code with your local community group, with your church group, just with your kid, your kid's friend, by yourself. We actually did this at work one day, and we were just like having the time of our lives. As professional programmers, it's just fun. But it comes with the lesson plans already built in. So if you don't know how to teach or if you don't know how to code, it basically tells you exactly what to do. Code.org also offers a bunch of training programs, so you can go get certified to be a Code.org educator. They're free, they're virtual, and it's pretty easy. Spend a couple hours on a Saturday morning. The kind of the really cool thing, I think, why teachers like Code.org so much, and of course, this is free, by the way. All this, the 2 tools I'm going to talk about today are just free. They're out there. Is it includes a learning management system. So that means I can load in my students. Either I can upload an Excel sheet or I can type them in manually, set them up their accounts, and I can keep track of what they're doing. I can drill down into specifically what they have done. I can see their final project, things like that. So you get a good idea of, are the kids actually working? If you're, you have 30 kids in your class or 20 kids, you might be walking around, but you don't really know exactly what they're doing. So you can easily go into the LMS and see what's happening there. And then kind of the cool thing too, really easily in Code.org, you can toggle to see the JavaScript code. It's not, I haven't been actually able to figure out how to do it with Scratch yet, but for kids, it's just the intro. I encourage them to toggle just so they can see what the code is actually behind the scenes. This is just an example of a class that I did. I did a Minecraft hour of a code with a bunch of 3rd graders. I had to school the teacher, but she didn't do any. Mrs. Spinelli didn't do any. But you can kind of see there are certain kids, depending on how fast they are, each one of these modules is, they get progressively harder. So for example, lesson 1, it'll actually walk you through it, and it'll just say something like, when you click run, have the sprite say hello, right? And then 2 will say, okay, you got that right. Maybe you didn't get it right, so these light green here means maybe it took somebody a few times to get it done, but they finally got it done. But they get progressively harder to, I'm going to do it again, till you finally end up at 14, which is your final project. You can share out. Kids love that because you can text it to your parents, play your game on the phone. So that's really, really cool. The kids get excited about that. Now I'm going to talk to you about Scratch. I love Code.org for certain things. I love Scratch for different reasons. The one thing I like about Scratch, if you have more advanced programmers, junior programmers, or if maybe sometimes, I won't even say it has to do with age. I really won't say it has to do with age. But all the blocks are available. Code.org, when you go in, there's kind of project templates. And so depending on which project you choose, you'll be able to do certain coding fundamentals. So for example, I have an example on here. My daughter made one. She actually prefers Code.org to Scratch, and I think part of it is because they have something on Code.org called Dance Party. That's what it's called, Dance Party. And so it's already set up. It's got the cool songs, but you can practice loops. You can practice triggering events. I don't think you can do variables in that one. But there's certain things you can do in there. You can't create a function. I don't think you can create a variable. You can have a conditional. So certain of the preset templates have certain blocks. In Scratch, it's wide open. You start literally for nothing. All the blocks are available. That can be intimidating for some kids, but for some kids, that's what they want. They don't want, some kids get very quickly bored with some of the Code.org things. So I kind of like having all the blocks available. You can create your own function, you can create your own variables. There's a really strong user community on Scratch, a lot of sharing of projects, a lot of remixing of projects. So, if you want to make a calculator for my 5th grade math class, you search up calculator, and here's a gazillion calculator apps that you can look at. One of the things I make sure to tell my kids, I want you to remix. It's good looking at other people's code. I don't want you to steal code. So in other words, don't remix something and pretend like you wrote that thing. So I had an example where, but you have to kind of be nice, right? Because we're in the spirit of aloha. You have to be nice about these things. I had a 3rd grader. She was showing me her final project, and I could tell this was not really my 3rd grader. It was just too good. And so, it's very quick to just ask, so, where'd you come up with this idea? I haven't seen anybody make a game like this. This is great. Well, I kind of made it a long time ago. I kind of forget how I came up with the idea. Okay. Oh, this is really cool how you did that. So how did you get it to bounce from this to this? Well, I kind of forget. I said, well, let's go look at the code. And so I'm going to see how you can find the code. So you can kind of get triggered. So I'm just like, it's okay that you look at something like that, but I want you to learn from that, right? I don't want you just to take it and start playing it and then say I wrote it because you renamed the file. So you have to attribute that this was a remix from somebody, and these are the changes that I made, and this is what I learned how to do. But anyway, there's a really good user community there. Scratch, you can work offline, so you can download it. I don't need internet access. That's great. And then I talked about the project extensions. There's Makey. What else is there? Microbit, Lego. I think they might even have Arduino. So if anybody does like Lego League, you might be using Scratch to get your Legos to do stuff. We saw somebody in Lego League last year at my daughter's science fair, created a, it was like a vacuum, like a Lego Roomba. And he had coded it up in Scratch. I was like, oh, that's pretty good, I like that. Alrighty. Oops, I'm in the wrong direction, guys. Alright, so that, if you have your laptops and you want to go out to scratch.mit.edu, you can. But I am going to go out here because I just want to show you what this stuff looks like. I've been talking about it for a while now. But, alright, so I'm going to come here to Scratch. Actually, I'm logged in here, but that's okay. So when you go to Scratch, you don't have to sign in. You don't need to create an account. If you decide you want to get out to your local community center and start teaching kids how to Scratch, I suggest you set up a teacher account because then you can set up everything in there and you can kind of create your own community so the kids can share with each other. But you don't have to do any of that. You can just click create and then you're starting to create. So like I mentioned before, you start off with a blank space, which can be scary for some kids. You have all your blocks over here, events, everything's open. And so, and you always come with this default Scratch sprite. And everybody's first program is Hello World. So we'll see if we can do Hello CPOSC or something like that. So I'm just pulling in the when flag clicked event, and very quickly you can say, I just wanted to say hello world, right? So I'm gonna drag this like the easiest block. So I'm gonna say hello CPOSC. That's it. I'm gonna run it, and he's gonna say hello CPOSC. And guess what? You just wrote your first program. And it comes as simple as that. Now it's kind of boring, right? It doesn't do anything. But for a child, just that I clicked something and I was able to make something work. That is enough for them. And then the next thing they're going to say is, oh, what else can I say? Oh, let me say this. Oh. So usually the second thing I would have after the first lesson, the second lesson I like to do is like to code a joke, right? So tell a joke through code. Kind of the cool thing about Scratch, I just want to touch on this real quick, is the creativity in Scratch is really cool. If you want to change the way this sprite looks or add a new sprite, you can either take the existing one, change its color, erase it, make things bigger, smaller. They have a big library of ones that are already available. You can start drawing. But the thing that I really like is that the kids can upload their own stuff. So if you're a really good artist, drawer, and we've had stuff like this, I want you to create that on paper like you already usually do. We'll take a picture of it and upload it. So now you've got a pretty sweet background, and now you have a sprite that you've truly made all by yourself. So that's kind of the world of Scratch. I want to make sure I'm being mindful of time here. Let me come back here. If you have any questions, just let me know. I'm not going to go to code.org because I want to talk about student projects, but if you have any questions, all right, we'll go right to student projects then. I mentioned the Flappy games, and maybe I wasn't really planning on playing these, but maybe I could. I'm just going to click on this one real quick because I want to show you. I don't think I'm going to click on all of them, but I want to show you the code behind, which is the most important thing, I think. So I can run this game. I could actually look at my Makey and plug it into something, so I don't even have to use the keyboard. Like I could be playing on my bananas or something. But if I'm going to run this game, right? Whoops.
I think it's on the wrong screen.
Yeah, we can't see it.
Oh, I'm so sorry. Let me go back. I might not be able to do it. Oh, I'm still over there. Okay. Yeah, I might not be able to. I don't know if I know how to do that.
Almost.
Say it again?
We just saw something else for a second. Where something was happening.
Is anything moving?
Windows key P.
Orange key P.
No.
Yeah,
Press enter
just-
mode to duplicate. Duplicate sheet.
Windows key.
Say it again?
P.
Windows key P. So you bring up a thing on the side of your monitor to switch from presenter
Oh,
view
you guys
to-
are so good. Thank you.
Good job.
Let's see. Let's see if you're right.
One more try.
The wrong
You're
one.
almost there.
There you go.
That looks good.
Did you see that? All right.
And then you can switch back, do it again to switch back to extend.
So if you click on duplicate, it'll show the same on both screens.
Let me try that. Let me try it. There we go. So yeah, so this is the game, a Flappy game that one of the kids made, right? And it already died. But really, I wanted to show you the code. That's what I was trying to get to here. Thanks for the help, guys. So here it is. It's block coding, right? When you click run, the sprite's going to flap. It's going to. There's obstacles. So this one's pretty interactive and actually not too bad. They're letting me score points. So this one plays normally. I can remix that if I want and do something different with it. I want to come back here now. All right, I see it now. Oh, yeah, this is better. Thank you. Here's an example of a Scratch project. Now this one's interesting. I ran I want to see inside of this. I ran a coding club for 3rd to 5th graders. I had 28 3rd to 5th graders. And that coding club ended in January. This guy, there's a few kids, I keep it open. Like, you can still go and do whatever. This is something that a kid posted like 3 days ago. And if you go and look, I can see, like, you know, he went and drew these different images for his sprite. One thing they really like in Scratch is, and this one he might not have, but they like to upload their own sounds. Be careful about kids uploading their own sounds, especially kindergartners through 5th graders. But this is a really cool animation where they're going back and forth, this teapot and this, I'm not sure what that guy is, maybe he's a piece of bread or something. They're going back and forth. But when I saw this, I was just like, this is a 4th grader. He's coming out here just randomly uploading projects. If you go back to his, you know, I have them learn how to write, press the green flag and it does it, so it's not very interactive. But this is my second project, and I would call it an animation. I made all of it. So right, so he's proud. He should be proud. He's probably like 9 years old, and he made this thing. So that's the kind of projects that kids can really work on. This was the food drive. I'm not going to click there, but kids created a Canverse instead of a Converse. And I don't know if I can zoom in on that, but you can kind of see like the wires all over the floor. Anywhere where there's metal, like not the cans, but like tin foil. You could touch this, and it would say something, or it would do something. There were like metal aglets on the shoelace that they made. So that one was really cool. Real fun stuff. Now I have up here, I talked before about using Makey Makey to make things interactive. I have it hooked up. I actually don't have it turned on because it basically works like your keyboard. So if, you know, I'm using arrow keys up here. I guess I could have used my bananas that are hooked up to the different arrow keys. But this would be like a whole separate lesson that I would do about circuitry. So, you know, you have to have a complete circuit for things to work. So if you think of a light switch, you can do a whole lesson just on what's conductive and what's not. So you would say, okay, bananas, yeah, they're conductive. I think one of the ones, I tend to like food stuff. I'm not sure why food stuff so much. But I brought in a bag of Skittles, right? So you hook up a Skittle, very easy to test. You think Skittles are conductive? Anybody? Raise your hand if you think Skittles are conductive. Or are they, maybe not the outside, but the question to the kids were, well, what about the inside? They're kind of gooey. Maybe they are. Let me tell you, they are not, but they really gum the heck out of your alligator clips. Same with marshmallows. Pretzels, you have the chocolate covered, they might be. So anyway, it's all a long way for me to say that you can really start playing with your food. So if I plug this up here, let me try again, guys. And I come here. I should have actually had someone volunteer to see if they can play Mary Had a Little Lamb. Somebody want to volunteer to play the bananas before? Because we're going to have lunch, so you guys can really play with your food then. Any banana players? Nobody plays the banana? Oh man. Really? Okay, let me see. Wait a second, let me see. Oh yeah, I guess it's good. Now my challenge is, oops, that's wrong. Right, so the kids can play the banana. We've actually done these with a bunch of other types. I don't know why playing with food is so much fun, but really if you want to get kids engaged, like if you can hook these up to, whoops. It's a very sensitive banana. You can hook them up to anything. It doesn't have to be food. It could be anything that's conductive. And they can make any sound. These are just piano sounds that came with. We've done stuff where kids, a lot of the kids I work with are playing musical instruments. They can record their own sounds and then hook them up. And now they're playing their own sounds. So it's not just the sounds that came with scratch, right? Yeah, so I was thinking, you know, if I had tropical fruits, maybe I could have done like steel drum, but I wasn't that creative until just a second. But anyway, so the world is available to kids. You know, my purpose now, I'm stuck in here. Let me get back to my slideshow. I don't want to, nobody's missing lunch. Here. All right, we're back to good. Thank you guys. Do my projects. That's that. Play with our food. All right. So now I just want to know if anybody has any questions about any of this stuff, or if you have done like stuff similar or different. I'd love to hear about it. Yeah.
Well, this is I got 2 kids, okay, and the one like reads real good and does like scratch and all that, and the other one's does whatever. But the thing is, like, I don't understand. Like, how do you be nice to kids?
So it starts with. I'm just kidding. Starts with your coffee cup, so I can go from there. So really, you know, honestly, the kids are into it. And as a programmer, I think I once told my husband one time, I could care less if I get another drop down or a grid, I just don't care. And so I started with the kids, I'm like, oh my God, this is so much fun. And seeing code through the way that they see it, like from a beginner's, and with these types of tools, I'm telling you, I wrote an article once, it was like, I haven't had this much fun coding in like a decade. And somebody's like, oh, what's the latest project you're working on? I'm like, oh, bananas. How do you be nice to the kids? It's not that hard. Most of the kids are just so into it, and they just want to start coding. So that's, you'll run into 1 or 2 different problems. One problem is somebody just continuously can't get signed in. And that's when you say, okay, is anyone else having trouble signing in? That's already resolved that problem? Yeah, help this kid out because he's needed. So then they like to help each other out. The other problem, not problem, but the challenge is you have kids that are fast. And if you say the assignment is to write a joke, and their joke is, you know, with black and white and red all over, it's a zebra with the measles. I'm done, but I start coming out, look, and you're just like, okay, you are done. But do you think, like, if you saw this, and you had never seen the joke, like, is it interesting? Is there a way for you to make it more interesting? Like, maybe you have the default black, the default white background. Can you just change that? Can you draw it yourself? So there's a bunch of different things you can do to kind of make kids think about, like, you're not done. Anybody who's ever written, like, you're really never done. You can always make it better until we get to the next project. But yeah, so I think just being nice, I don't know. I go in and they're just so happy, honestly. They're just so happy to be doing something that's not schoolwork, probably. Yeah. Yeah.
I feel like when I've facilitated with Scratch, I observed the very same thing I observed with my grown colleagues, is the 2 things we struggle with the most are creativity and collaboration. So like, if it's in grade school, it's like sometimes there's one kid who takes the responsibility and the other kids are just happy to, and I have peers that throw me code without even testing it. Like, it's just normal, it's human, it's not a kid thing.
Yeah.
And then the creativity is like, we just naturally do the same thing over and over again, even if it's, how do you have transitions, like how do you help the repeated meow sounds graduate to something more interesting with Scratch?
So usually I will say, okay, so let's talk about the first thing, which was how do you, if you're working in a team.
Yeah.
So what we'll do is we'll actually divvy it out, like what are the tasks that we need to get this thing done? And so you're gonna do this, and you're gonna, and that's what happens, right? So then we specifically assign who's gonna do what, and that's what you're gonna do. Graduating past the built-in stuff, to me, you only need to have one kid who does something hysterical, no matter what that is, and then the rest of the kids want to repeat it. It doesn't. It can't come from me. So usually, as I'm going around showing, like, let me see what you have. You know, kneel down, show me what you got. And they show me, oh, this is so cool. Now, and you could even say, this meow sound, you know, it sounds okay, but it kind of sounds like all the other meow sounds. Can you think of a way to make it, like, you know, you can record yourself. Go out in the hallway, come back. I want to hear the best cat sound you can make. And then they come back, they're all ready to roar, right? Yeah. So you can do stuff like that. Just keep challenging, like, you know, it sounds good.
It sounds like you're encouraging peer modeling and then pushing a little bit like, hey, do this in front of your peers.
Yeah, I noticed, I don't know if my daughter is unique in this, but she definitely wants to listen more to her friends than to me.
Yeah.
So yeah. I kind of just have done, I'm sure you don't relate at all. So I just kind of taken that, and that actually seems to work a lot better when they see it from their friends and it's not the teacher telling them what to do.
Yeah.
Yeah.
Another piece for that one I found is remember that they're out of curiosity, and while they may have a smaller frame of mind than we do, all you have to do is push the boundary a little bit at a time. Remember that they don't have the decades that we have, but they do have the pure curiosity that want to do something additional. So as simple as the joke and change the background, it could be, okay, but make it a knock-knock joke. You're going to need a second person.
Right.
And now they've got a whole separate, but very separate task that can learn about interaction at the same time.
Yeah, that's a really good point, right? Especially the knock-knock. I like when the kids work together on the knock-knock jokes. I will say about the jokes, another thing is like learning experiences for me. You know, I have 3rd to 5th graders code a joke, and I'm thinking, okay, they're going to tell knock-knock jokes or something. And so they're going around, show me what you coded. I'm so excited. I got this joke that my dad told me. Does the joke? Oh my gosh, yes, this is borderline inappropriate. No, my dad told me this. I'm like, oh dear Lord. I was like, okay. So you have to think like, would you tell your teacher? Would you tell the principal of your school this joke? Yeah, because my dad told me. I'm like, okay, it's borderline, but oh, it's just right there on that edge. So you will often get unexpected. So I'm like, okay, note to self in the future, I got to be careful with the jokes these kids are telling kids. You can't just assume because they're in 3rd grade it's going to be clean. Yeah.
Just a thought here, but so what age ranges are you usually targeting here with your? I
do any elementary school kids. I like to work most with the 3rd to 5th graders because they're good readers. 3rd to 5th graders because they're already good readers. But having said that, working with kindergartners is, I don't know, it's fun too, just different, and your expectation has to be, like I said about this, like don't go in thinking you're going to finish an hour of code on code.org with kindergartners. It's not going to happen. If your expectation is we're going to learn how to do an algorithm that makes 16 rectangles, you all will be very happy. Because otherwise, you're rushing through trying to explain what a condition is, and they're just like, checked out.
So I just think to continue that thought, but we're just talking earlier here about creativity. How do you like encourage that? Do you find it true that the kindergartners have more novel solutions?
I don't know if they're more novel. I think sometimes they don't overthink it. 5th graders will overthink something to the point where it's like you're missing the obvious. So I don't know that they're necessarily more creative. I have a lot of, I think a lot of the kids I teach are very creative, just in different ways. And so like I said, you just don't know, you truly don't know what you're going to get. Every kid will interpret your assignment differently. Yeah.
So switching gears a little bit, I love the physical nature, so like the Makey Makey is really interesting to me. I have a hard time with the creativity where it's like, okay, this is really cool. I'm sure my kids will have a really cool idea, but it's hard for me to like, why don't we start with this and then you take it from there? Do you have any interesting?
Yeah, I have stuff where, let me good example. So part of it is like the way my brain works, right? Like I'll see something, I'm like, oh, we could totally do something for that. But the kids don't see it. So some of it is me modeling things, but I don't want to tell them the answer, right? And so I just model like, can you take this concept and apply it in this different way? So an example with the food structure, right, where you're doing that, those kids now, like we built that together, right? That was some of it was my ideas. What they said was their idea. They had to do research, right, to have it say whatever it's going to say. But like I have those kids now that like have already thought of that. So they're like, oh, can we do something like we did in that and put it over here? So it's not necessarily me. I've already given them, like that's a pretty good example. So you can extrapolate from that and take components of that and put it onto something else. But getting them there, I think a lot of times initially you just have to show them because they don't have the frame of reference to even know that it's something, it's a possibility. So show them, give them the structure, assign the tasks, and then they learn how to do it. And then to your point, now can you think of a different way to apply just this part of that? And you'll be surprised what they come up with.
So we are over time.
Oh, I'm sorry about that.
No, that's okay.